Hello. Trying to find my pen. Found it. Okay, Chapter 2, Lesson 2 of Advanced Algebra. We're going to be looking at linear equations, and I'm going to move quickly through the vocabulary section here in the first video. It should be mostly familiar to you. You probably heard it before in algebra class, but we're going to need to review it, and we're going to spend some time on it in the coming videos. So we're going to look at some linear equations, but again, I want to talk about some vocabulary first. Let's go ahead and begin with the vocabulary. First of all, a linear function. And a linear function is a function whose graph is a line. And this is important to understand. One of the major emphasis of this year in advanced algebra is we're going to be taking and looking at the connection between a function rule, which we talked about before, which is just simply an equation that's equal to y, or an algebraic expression that's equal to y, and its connection to the graph, or what the picture of that algebraic equation looks like. And we want you to be able to look at an equation and immediately get a picture in your mind of what that graph generally looks like. And that is the major emphasis of the course. Linear functions are equations that, when you graph them, look like lines, thus the name linear function. A linear equation is an expression whose the exponent on the x is 1. So out of all of the x variables in the equation, and we'll be looking at very easy ones to begin with, the highest exponent is a 1. So just the letter x, even though the 1's not written there, the 1 is there. So x is the highest, or 1 is the highest exponent on the x variable. The solution of a linear equation is an ordered pair, an x and a y, that makes the equation true. So when you substitute in the x value into the equation on one side, and then you substitute in its corresponding y value into the variable on the left side, then, and you simplify the right side, then the expression is true. It's going to create a true statement. And any ordered pair that does that is considered to be a solution to the linear equation. Now let me make a quick connection here. We talked about the connection between the algebraic expression and the picture. What is the picture? The graph of a line. What is a line actually? If you think back to geometry last year, a line is just a series of points that extends forever in opposite directions. So a line is simply a bunch of points. Now if the solution to a linear equation is any ordered pair that makes the equation true, what do you think that line is a picture of? Well, it's actually a picture of all of the ordered pairs, all of the x values and their corresponding y values that will make that equation true. And that's what a picture is. It's actually a listing of all of the ordered pairs that will solve that linear equation. So if you take any ordered pair or any point on that line, you take the x value and its corresponding y value of that line, and you substitute it into the algebraic expression of that line, it's going to make that equation a true statement. That's why it's a solution. So the connection is there. The graph, and any graph that you see actually, is actually a picture of all of the points that will satisfy the algebraic expression of that function. So that's the connection that we'll be looking at, and looking more in depth at as we go through the year. Okay, some more vocabulary. The independent variable, we talked about, those are domain values. Those are represented by x in the equation. The dependent variable are the y values represented in the expression, or is the y in the equation. The range then is a listing of all of those. And then so in a situation like this, here we have y, this is the dependent variable, and x here, this is the independent variable, and notice that the highest exponent, the exponent here of the x, is 1. Therefore it is a linear expression, or a linear function. A couple of more vocabulary words. Y-intercept. Intercept means to cross or to intersect. So the y-intercept is a point where the line crosses the y-axis. And the x-intercept is the point where the line crosses the x-axis. And these are very important points to be able to interpret when we're looking at their application to real-world situations. So they're very important points that we want to be able to identify, and then use the different equations that we have to locate them, because we're going to be using those when we apply them to real-world situations, and then interpreting the data from there. Okay, I think we got one more page of vocabulary here. Slope. You probably heard rise over run, and that is correct. It's a ratio of a vertical change, that's a rise, vertical, over or to the horizontal change, that's the run. And a ratio means fraction. It gives us the rate of change. Now this is the very important phrase because you'll see this in word problems, and so when you see this you'll go, aha, they're telling me what the slope is, because that's what rate of change means. In equations, it's represented by a lowercase m. So when you're looking at general forms of equations, you're looking for, they're going to have all these letters in them. We want to look for the lowercase m because that's where we will put the value of the slope. Now this is another very important point I want to make about advanced algebra. As we go through this year, we're going to be given these general equations. In other words, a general equation is actually something that has mostly, if not all, variables. The equation y equals mx plus b, which you've heard before and we'll talk about more later. You have all letters. And the major point or focus of the course, another focus of the course, is that you know what each one of those letters represent, and then how to calculate the values that go in for those variables so that you then end up with a relationship between y and x, because now you have number values in where these letters are. So we'll talk more about that as we go forward, but m in the y equals mx plus b, the m is where you would put the value of the slope once you calculated it. The slope formula, how do you calculate slope if we're looking for the value that goes in there? Again, rise over run, you've probably heard this before. Y sub 2 minus y sub 1, and I've made a mistake here. This should be x sub 2 minus x sub 1. And it's very important that these are the same order, because whatever y value you choose first in the numerator, because it's a subtraction problem, the order matters. Its corresponding x value must go first as well. These x and y values are coordinates from points that are on the line. You take the y coordinate of a point minus the y coordinate of a separate point, that gives you the vertical change, and then you take the x coordinate of one point minus the x coordinate of that another point, that gives you the horizontal change. But these points, these x and y values, have to be in the same order because subtraction is not commutative. So make sure you make a note of that. These are out of order in the denominator. This should be x sub 2 minus x sub 1, and that means that this y value that you choose first, its corresponding x value must be first in the denominator. Okay, and we'll talk more about that as we move forward. Okay, so that's some vocabulary that you need to know. In the next video, we'll start looking at some of these linear equations, and we're going to look at standard form first.